Hey guys, welcome back to another video. So here we'll be looking to try and determine the Wronskian of the second order ODE. Now we're not actually going to try and figure out what the definition is or what it's all about. All I'm trying to show you guys is how to compute it and perhaps what we can do with it later, yeah? So let's have a look here. Now the first thing you need to know about the Wronskian is the formula of it. Well, one of the definition of Wronskian is that it's equal to some constant times the exponential of an integral of some function called px, where px is the coefficient of the first OD y prime over the second. So in other words, we could say that let px equal 3x, the coefficient of y prime, over the coefficient of y double prime, which is 2x squared. And simplifying that, we're just simply going to get 3 over 2x. Okay. Now with the Wronskian, all you're really going to see that in my later videos is that a Wronskian could be used to simplify a second order ODE into a first order ODE if you have some relevant solutions, yeah? If you have at least one of the two solutions. Now let's keep going, yeah? So to obtain the Wronskian, this is just simple maths now. The Wronskian is equal to the constant times the exponential of minus the integral of 3 over 2x dx. Well, since 3 over 2 is a constant, you can take it out. So it'll be minus 3 over 2 integral of 1 over x dx. And now simplifying this, well, the integral of 1 over x is just the natural log. So CE minus 3 over 2 times ln x. Now, a cool feature about this is that this constant c is already taken from this Wronskian, yeah? So we don't need to write plus c or like another plus c. Now, simplifying this term, well, one of the properties of the natural log is that minus 3 over 2 becomes a power of x, yeah? So we can say, therefore, the Wronskian equals CE ln x to the power of minus 3 over 2. And now we just cancel e and ln, so these two go. So finally, the answer is c times x to the power of minus 3 over 2. And we're done, guys. Now, typically, what we do to c, we usually just set it to equal 1. And that pretty much gives us our Wronskian expression.